Today we're going to discuss scheduling of jobs and transformations and advanced job concepts. So I've got a transformation in front of me now. So I'm in my PDI desktop tool and I'm using Pentaho version 4.3. So this is just a dummy transformation. It doesn't do much. You can see it just generates some rows and then there is a dummy step. But what I'm going to use it for is to demonstrate how to schedule this transformation. It's a very straightforward experience if you do have a data integration server. So I'll just close this for a second. So I am connected to a repository. Once you have the data integration server set up, your repository connection will look somewhat like this. So this would be the repository URL. Right now I'm running this on a local host. And I connect with my username and password. And so this repository holds all my transformations and jobs that I develop. So for example, this is the one I want to open, got my history. So once I have that repository and I have the data integration server available, I can schedule like this. So I go up action, schedule, and it comes up with a little calendar. For example, I want to say run every 5 seconds just for a test, and I click OK. So then in the top right hand corner I can see my scheduler, and I can see that this transformation has been scheduled by me, and when it's run last time and when it's going to be run next time. So this one is now running every 5 seconds. If I wanted to stop it, I just hit stop the scheduler and then it's gone, it's not running anymore. I should go to. If I want to delete my schedule, just like that. Okay, so it's a very simple visual way to schedule jobs or transformations. For a job, it works in exactly the same way. You open your job, you go action, schedule, and select the details. Now what usually happens is obviously we schedule jobs rather than transformations. And if you do have a job, I'm just going to open one I have prepared. This one. So if I have a job that runs 2 other jobs and I want to schedule them to run at the same time, there is an option by clicking on the start button. So just to run click, launch next entries in parallel. And you see if I unclick it, this is the usual hop. If I select this option, it gives me a little warning. And it warns me that the system, the tool, is not going to check whether it actually makes sense to run these jobs in parallel. So what it means that if I update a table in here and I update the same table in another job, which doesn't make sense, but the tool is not going to pick it up. So I need to make sure that if I schedule things to run at the same time, I'm aware of why I'm doing it and that it's going to make sense. So it gives me a little warning about that. I say, okay, I understand. And then I see there's the 2 lines here. It means that these jobs are going to run in parallel. Now in this scenario, one of the jobs is probably going to finish earlier than the other, and they will not be synchronized in this case. If I wanted to make sure that the jobs have a common finish point and they're synchronized, what I can do is have another job that holds these 2 jobs. So now I kick off this one. This job has these 2 entries, and once this is finished, I have this next step. So it means that these 2 jobs will effectively finish at the same time in here, and then I'll only have this step executed once. Okay. So yeah, that much to scheduling. I'm just going to close all this. So the next big point about advanced job concepts is we're going to have a look at a very pretty example, and it's pretty much all about exchanging data between transformations. So I'm just going to start with this one, and maybe I'll start with this one. see what it does. Okay, so this is a very simple example that just shows us how we can put some result from one transformation into memory and then pick it up in the next transformation. So the way it works is, in the first transformation, what I do is I say copy rows to result, and it will put my result into memory, so that in the next transformation I can pick it up by simply saying get rows from result, and it will get them from memory. So it's essentially the same as if I had just these two steps and the next step from the other transformation right after it. So the reason we might want to do it is if there is something happening in between, we just want to separate it for clarity, or if we want to use the rows in the result set to, say, loop another transformation through them. We'll go into this example in a second. But the benefit of using this step is that it goes into memory, so it's really fast. There is no extra time spent on, say, writing the data into a text file or database or any other output, right? So the next one, we will have a look at this example. This is quite a long example, but all it does, effectively, it reads all my all the tables in a database, and it counts the number of rows in every table, and then generates a text file for every table, and writes the number of rows into from that table into the text file. So it's essentially like a little database analytics tool. Okay, so let's see how that happens. So first of all, we want to get the list of all the tables that we have, right? And this is our magic step, copy rows to result. So this is a simple SQL statement, show tables. It's connected to a MySQL database. So if I do preview here, I'll just get these 5 tables. And the reason it's only 5 is because I've actually limited it here. So I just select this and I put this result into memory. Now, why I did this? In this job, I will kick this job off for every row. So it's creating a loop. Essentially, for every one of those 5 rows, I will execute this job. So I execute it for the first row, then for the second, and so on, 5 times. Okay? So if I actually run this, just so we can see how it loops, and we see here at the bottom, we execute this job 5 times. And we could have done the same on a transformation. There is a execute for every input row option as well. Okay, so now let's have a look what this job is actually doing. So first of all, we execute it for the first row. It defines a variable. So we get the get one table name. We get the rows from result. So it's that first one, and we set a variable. And what I'm doing here is I'm just writing that variable into log table and into the log, just so I can see what actually is going on and make sure that this variable is defined. We don't really need it. So once I've set the variable, I'm then going to reuse that variable in the next transformation. Now, this is an interesting thing about variables. You cannot set the variable and use it in the same transformation. And the reason is that in a transformation, all the steps get started at the same time. So you will try to use the variable and set it at the same time, which is not going to work. So even though we have a flow of data in the transformation defined by first step, a hop, and the next step, all the steps get initiated at the same time. So this is why we set the variable here so that we can use it here. Now, having another look at the variable, the step itself has this little diamond shape, and I don't know, what is that, $1 in the middle? So anywhere in PDI, if you see the same sign, it means that you can use a variable. So even in the log, actually, yes. Here you see this sign, it means I can reuse an existing variable. So in this second transformation, what is happening is, I'll show it here, this little diamond means I can reuse that variable that I have set. So I'm using it here by inserting the same dollar and the squiggly brackets. So what is going on here? I've got a select statement, table input, select count from the table name. So I'm using this variable, and I have to say replace variables in script, and that will execute. So if the variable is, for example, my table customers, it will be select count star from customers. And then the result is going to get written into that into the text file, which name will depend on the same variable. Extension text. Nothing magical here. I'm just saying it's a number of rows, so that's that one field, and it goes out there. So if I have a look at this again, so I just run this job, we'll see this one runs 5 times. I can go into the log, and I can see that the value for the table name keeps changing. So first it's customers, then it's customer, then it's department, dim time, employees, and so on. So all that comes from this first transformation. This one here. So we're looping it 5 times and we're changing the value. Now, I can have a look at the result set. So in this job, my second transformation writes this, I'm just sending it to my desktop. So I can go have a look at the result. These are the files: customers, customer department, dim time, employees. If I open this file, that's my count of rows. Now, there is another interesting thing we're doing in this same example, which is this last transformation. And what this transformation is doing is it's going to take the files from result and put them into text output. So get files from result is different from get rows from result. The rows were the rows that we put in memory specifically. The files will list us all files that have been created during this process. And for this to happen, when I created this file, I've ticked add file names to result. So it means that all these file names that come through here will get added to result, so again saved into the memory. And from that memory, we can grab it using get files from result. And this is just going into a text file called temp. So again, just run it. All good. And this is my temp. And these are all my text file names. Right. So this example is actually quite tricky because it shows us a few things. It shows us how to use copy to result set and get from result set. I'll just close that. Then it shows us how to loop through a transformation and execute it for every row. Then it shows us how to set variables, and don't forget that to use that variable you need to be in the next transformation. And it shows us how to use file names in the result in memory, this one. And so these are basic concepts of moving data between the transformations. So you see that this is nothing magical from the logic, from the flow of this transformation. it's quite straightforward. So we're just setting variables, we're counting number of rows, we're putting it into text file, but it's quite a tricky way, or quite an interesting way of reusing the data in different transformations and exchanging the data, moving it from one end to another. And so far in this example, it all has happened in memory. What if we cannot use this very effectively? So say if your result set is very big, maybe a few hundreds of millions of rows, so you won't be able to put it into memory, or you don't necessarily want to. One obvious thing is we could write the result into a text file, such as CSV or TXT file, whichever. But then what happens is if you write your results into a CSV file, there is some formatting that happens on the way out, and then to take the data back into PDI from a CSV file, again you get to deal with the format. What you can do instead is, I'm going to show you another example. It's called serialize or deserialize. So what this is doing is it is creating a physical file in your computer, but it will keep the formatting as PDI is using it, so that when you then read from that file, you don't need to define your integers or numbers or dates, which is always a little bit tricky. So all I'm going to do here is I'm using the step serialize to file, and I'm calling this file customers.csv, and I'm just taking all the data from my customers table. It's just a very simple thing. So I run this and it's written 122 rows. I can have a look at this file. And if I try to open it in a text editor, it's actually looking quite funny. So this tells me that this is not a normal text file, some sort of binary file, a mixture, and it's got that particular format that PDI needs to keep the data structure, but it's not readable. But what I can do with it quite successfully is say deserialize from file. So select the same file, and then I just do text file output, something that I can actually read. I'm going to run this. 23 rows. And this is the one that I actually can read. But when this comes in handy is if you have some temporary files that you create in the process. So maybe you have some data manipulations or some calculation that really is complicated and you need to have that intermediate output. So this is when it comes handy, and you can't hold it in memory, maybe because you have different result sets and you need to name them, or maybe it's just too big to go into memory. So this is a useful technique. Okay, the next little trick I would like to show you is, again, if you have quite big, this one, if you have reasonably complex transformations and calculations, what we can use is so-called subtransformation. So this one comes in handy if you have really big complex calculations, or you just want to reuse your transformations. So what is happening here? Let's have a look. I have some data coming in, and it's very straightforward. Just stores, sales number, month, and the budget. And I can preview the same data, nothing interesting. I can preview it at this stage, and it's the same columns. Now I have a little plugin. This is a subtransformation that does something. At the end of this something, let's see, if I do preview, I've got an additional column, which is my variance. Now this subtransformation could be anything. It could be really big, or it could be just very useful. So because I can reuse it in many different other transformations and jobs, and I wouldn't have to change hundreds of them if it changes. So I only have to change this one. If I open this, it's just another normal transformation. In this example, very simple, but imagine it would be much more complex. Or maybe this calculation could change. And if it's something that you reuse regularly, that you might want to have it defined once and then just point to this subtransformation. So to make sure it works, we need to define a so-called mapping input and a mapping output. Mapping output is very simple. It only has a step name, nothing else. The mapping input, you could specify the fields that you would like to use from the main transformation, but if you leave it blank, it just takes in everything. So this is basically where we plug in to this one. If I double click on this step, I see that I have specified this transformation in here. And in this case, because I want all all columns to go into it and all columns to come back out, I haven't actually specified anything in my input or output. So this is the simplest way. What I could do if I had a few inputs, so for example, in here I had several of these mapping input steps. I could have it. Maybe I'm calculating different things or merging the data. So then I would say, okay, I have multiple mapping input steps, and then I could choose which step I'm using. So that's my mapping input. And I could do exactly the same for my output. Yeah, but if we only have one stream of data and we're passing all fields into the subtransformation, there's no need to define anything extra. Okay, and I think that's all I wanted to present today. So we've gone through scheduling, running jobs in parallel, exchanging data between transformations, using mappings, copying row to results, variables, and serialize to file function. Thanks for attending. Yay!